Welcome back, students. This is the session 25 of NEET Physics. The chapter is Rotational Motion, and today I have taken one question from the previous NEET examination. The question is written on this board. The question is a disk and a solid sphere of same radius, but of different masses. They roll off on two inclined planes which have the same altitude and the length. So which one of these two objects will get down to the bottom first? So there are four options here. First one is the sphere. Second one is that both the this disk and the solid sphere they will reach at the same time. Third one is that it depends on their masses, and the fourth one is the disk. So here the disk and the solid sphere they have the same radius. Disk and the solid sphere have same radius. Say it is R, first thing, and the inclined planes have the same altitude and the length. That is, this is the inclined plane. Let us say this is the inclined plane. I'm just drawing it here. So this is the altitude and this is the length. So this is the inclined plane. So if this altitude, so there are two inclined planes. Means on one inclined plane a disk is rolled, and on the other inclined plane a solid sphere is rolled. Like this one. This is another inclined plane. So on this inclined plane, a disk is rolled, and on the other inclined plane, a solid sphere is rolled. So since the altitude and the length of the inclined plane are the same or are equal, that is, if this is the altitude, let us say it is h. So the altitude of this plane will also be equal to h. Let us say the length is L. So the length of this inclined plane will also be equal to L. So since this altitude and the length of both these inclined plane are equal, therefore this angle theta, if it is, I'm just denoting it as by theta. So this angle will also be the same. Now the acceleration of an object moving on an inclined plane is given by g sine theta divided by 1 plus I divided by mr square, where theta is the angle of inclination of the plane, I is the moment of inertia, where I is the moment of inertia of an object about an axis passing through the center of mass. Theta is the angle of inclination of the plane. Angle of inclination of the plane. Okay. M is the mass of the object. And R is the radius. Okay, so this is the formula which I will be using to solve this problem. A is equal to g sine theta divided by 1 plus I mr square, where m is the mass of that object, r is the radius of that object, I is the moment of inertia of that object about an axis passing to the center of mass, g is the acceleration due to gravity, and theta is the angle of inclination of that plane. So so in this question, g sin theta will be constant. This means the value of sin theta in both these two cases or will be the same. That is, the value of sin theta for this plane and the value of sin theta for this plane will be equal. G is constant. So here I will be first of all finding the acceleration of this disk when it rolls down this inclined plane. So let us say I am just denoting that acceleration of the disk as a disk, which is equal to g sin theta divided by 1 plus I, moment of inertia of the disk about an axis passing through the center of mass. The moment of inertia of the disk about an axis passing through the center of mass is given by 1 by 2 mr square. This is the formula. So I will be using this formula here and I will be substituting this value here. That is 1 by 2, this will be equal to mr square divided by 2 into mr square. So I have substituted this value in this equation, and so I have got the value of this acceleration of the disk when it is moving on an inclined plane. This is equal to this mr square and this will get cancelled out, and I will be getting as 2 by 3 g sin theta, or we can write it as 0.666, or we can write it as 0.66 and we can just write it as 6.67. 0.667 g sin theta. So this is the acceleration of the disk when it is moving on this inclined plane, having this is the acceleration of the disk which is moving on an inclined plane where theta is the angle of inclination. So I have got this value. Now I have to find the value of the acceleration of the solid sphere. So I can just write it here now. Here the acceleration of the solid sphere, I am writing denoting it by ASS. This will be equal to g sin theta divided by 1 plus I. Now the moment of inertia of the solid sphere, which here I am denoting as ISS, is equal to 2 by 5 mr square. So I will be substituting this value in this equation. So this will be equal to 2 by 5 mr square divided by mr square. So this will cancel out. So finally what I will be getting is 5 plus 2 7, 5 by 7 g sin theta, or it can be written as 0.71071 307428 g sin theta. So from here you can easily see that the acceleration of the solid sphere, is more than the acceleration of the disk. The acceleration of the solid sphere is equal to 0.714 g sin theta, and the acceleration of the disk is 0.667 g sin theta. Now g sin theta is same for the solid sphere and for the disk, because theta is the same in both the cases. That is, the angle of inclination of both these two planes are equal. So g sin theta will be the same for this solid sphere and for the disk also. So what we are getting is that the acceleration of the solid sphere is more than the acceleration of the disk. Okay? So in this, so since the acceleration of the solid sphere is more than the acceleration of the disk, therefore this sphere will reach the bottom first. So the correct option here is A. The correct option is A. And this question was asked in the NEET examination few years back. So in this case, the most important thing which you have to remember is this formula. This is the formula for calculating the acceleration of an object which is moving down an inclined plane. Okay, so using this formula you can easily calculate the acceleration of this disk and the solid sphere, and since the acceleration of the solid sphere is more than that of the disk, therefore the solid sphere will reach the bottom first. So the correct option is A. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is rotational motion. And so till then, have a nice day. Bye.